Okay, so hey everyone, welcome to today's lecture on AWS EFS. This is called as Elastic File System. So this is a little bit different than what we studied regarding EBS, which was block-based storage. So Elastic File System is it could also be thought of as network attached storage, right? So NAS, and it supports the NFS protocol and the SMB protocol. So it allows you to attach file shares across multiple EC2 instances. So when we studied about EBS, we saw that we could attach only one volume to one instance, and you could attach additional volumes also, but then that one volume couldn't be shared across multiple EC2 instances, right? So that was the problem that we faced. So EFS actually goes ahead and solves that problem, wherein we can have petabyte scale data storage and exabyte scale data storage that we can have across multiple EC2 instances, and all of the EC2 instances are mounted onto the same volume onto that file system. Or you could have different mount targets for different EC2 instances to be mounted on different volumes on that EFS file share, right? So it's very much possible. So let's go ahead and learn about how what benefits it brings us, and this could also be used for your on-premise infrastructure. And we will also see as to how we can go ahead and set this up, and we will look at what mount targets are, what are the features that it brings us, and then we'll go ahead and do a practical demo wherein we will have two EC2 instances that share the same EFS share, right? So Elastic File System provides a simple, scalable, fully managed Elastic Network File Storage, so NFS file system for use with AWS cloud services and also on-premise resources. So if you're going to connect this with your on-premise infrastructure, so you should have at least a VPN connection or a direct connect connection, because this is going to reside within the AWS cloud, within the VPC, right? And your on-premise infrastructure is in a separate network. So you should have a network reachability between your on-premise infrastructure and AWS cloud's VPC, within which the Elastic file system is there, right? So it is built to scale on demand to petabytes without disrupting applications, growing and shrinking automatically as you add or remove files. So this was one problem that we faced with EBS volumes, was that we couldn't scale our EBS volumes on the fly. We couldn't shrink our EBS volume on the fly. So we had to go ahead and modify our EBS volume to increase the size. But when you're using EFS, you don't have to worry about modifying the size according to your own need, and how much storage you are storing in that EFS file system. For that storage alone per GB you are being charged, right? And it eliminates the need to provision and manage the capacity to accommodate the growth also. So everything is taken care of by AWS in order for us to even grow up to petabytes of storage, and also shrink down to the storage that we would like to have for our EC2 instances and the applications that we host on it. So EFS offers two storage classes. So we have the standard storage class, and then we have the infrequent access storage class. So it's pretty similar to the storage classes that you studied with S3, right? And the EFS IA, which is the infrequent access storage class, provides price per performance that's cost optimized for files that are not accessed every day, or not accessed on a frequent basis, right? And by simply enabling the lifecycle management also on your file system, which was a new property that they released, files not accessed according to that lifecycle policy you choose will automatically be transitioned from the EFS standard storage class to the EFS IA storage class. So this is also something that we can remember, that is similar to that of S3's lifecycle transition policies, wherein we can transition our objects within this certain amount of days to a different storage class. Over here, it depends on the access, right? So again, Amazon ES is a regional service, right? So it's a regional service, and it stores data within and across multiple availability zones for high durability and availability within that region. And EC2 instances can access your file system across availability zones, regions, and VPCs. If the VPC has a peering with another VPC, you can still use Elastic File System. But for on-premise infrastructure, you should go ahead and use a direct connect connection, which is a dedicated leased line connection through a direct connect partner. Or you can set up your own virtual private network connection, which is site-to-site VPN connection with your on-premise infrastructure, so that you have network reachability between your on-prem infrastructure and your AWS cloud, within which your EFS file system is residing. Right? So how this generally works is you go ahead and create your file system in the EFS console, which we'll be doing in a second or two. And we have to choose your performance mode or throughput mode. So the performance mode is a little bit more costly. We are going to go with the throughput mode, right? So the performance mode can be associated with something along the lines of provision IOPS, and the throughput mode could be thought of something like general purpose SSD for your EBS volumes, right? And then you go ahead and create a mount on your EFS file system for EC2 instances which support the NFS version 4 protocol. and then you mount your EFS file system on your servers using that NFS4 from on-premise also, if you would like, right? And then you can go ahead and test and optimize the performance for your workloads. You can also move data into your EFS file system from your on-premise sources. You can also share the file data across multiple EC2 instances. And even at some point of time, if you want to share the data with EC2 instances in the cloud and with EC2 instances, sorry, not necessarily EC2 instances, but instances on your on-premise infrastructure, you would be able to share this EFS volume across multiple EC2 instances. So that's the base of how EFS works. So some of the use cases are data scientists can use EFS to create their own personalized environment with their home directories, storing their notebook files or their machine learning training data or their model artifacts. So SageMaker integrates, Amazon SageMaker is a machine learning service that is used to build, train, and deploy machine learning models. And it integrates seamlessly with EFS for training jobs, allowing data scientists to iterate quickly, and it has a really good performance. So recently, they have also increased the EFS performance by at least 400%, right, this year. And Amazon EFS also provides a durable, high throughput file system for content management systems and web serving applications that store and serve information for a range of applications like online publications, archives, and websites, and so on. And even media workflows like video editing, studio production, broadcast processing, sound design, and rendering often depend upon shared storage to manipulate large files. So if suppose you have a team of video editors who need access to the same file on and even the same directories within the EFS file share, instead of having multiple EBS volumes, you could have one EFS file system that stores all of the videos in a directory, which people can go ahead and edit and work on it. In parallel, right? So that's the reason why you would mount, multiple EC2 instances to the same file system that you create. And this is also ideal for container storage, providing persistent shared access to common file repositories. So containers are an integral part of building microservices. They are very quick to provision, easily portable, and provide process isolation. So containers that need access to the original data each time they start can take advantage of a shared file system that they connect to in regardless of whichever instance they are running on, right? So you can go ahead and use the EFS provisioner for Kubernetes. It is available through a Helm chart deployment. And by using that, you can go ahead and install your EFS provisioner onto your Kubernetes cluster. And then you can go ahead and create a file system on EFS, wherein all of the containers that are being spawned onto your Kubernetes cluster is using the EFS as one of its storage classes. And it's going and so each and every container is getting its own mount on the EFS file system, right? So irrespective of wherever these containers run in a cluster, irrespective of the node that these containers run on, they automatically get access to the same file system that they are connecting to, right? So these are some of the use cases for EFS. So now let's go ahead and do the practical lab regarding EFS.